I found the dongle. Yes, right. I recall seeing the results. Hey, there we go. Don't make the dongle cry. Okay, so it's after lunch. We need to, we will pretend that I've been introduced. Does anybody, it doesn't matter if you know who I am. I'm going to talk about Wi-Fi. Perfect. Sold. Now I want to know who you are. Does everybody in the room consider themselves a geek? Come on, it's okay. We're friendly here. Do you consider yourself a Wi-Fi geek? Does anybody want to come up and do this while I sit in a food coma? No. Okay. So we're going to talk about what Wi-Fi features and technologies. I've given this talk a few times, and I'm so excited to be able to do it for us here as geeks, because we can actually talk about some of the things where most of the time people just glaze over. You might glaze over too, but I'm just going to, we'll chalk that up to lunch. And then that'll be okay. We'll talk about mesh, but we'll talk about a lot of other things too. We'll talk about how to pick the right router, not just for your home and your clients, but your business too. All of that good stuff. And I'm going to allow questions throughout, but I reserve the right to change that rule if you get unruly. So, because we do have a time thing going on here. How long is this supposed to, I should know this. It's just 50 minutes? 3 hours. That's usually how, Q&A usually takes about 2.5 hours with a session like this, so. Perfect, thank you. Okay, cool. So we are going to talk about initials with Wi-Fi. And I'm going to tell you that there are 2 times in this session that I'm going to lie to you, and then I will come back and correct that lie, and this is about to be one of them, so it's okay. With initials, we have, where are we here? We have B, we have A, we have G, we have N, we have AC. There are others that don't matter in today's world. And the reality is each of these initials just means how fast it can go. Of course, behind the scenes, it's really a modulation thing about how we're manipulating the radio waves in order to get them to go faster, even though it's all the same frequency, at least with some of these things. Each of them describes basically speed versus bandwidth versus distance, and that's how that's going to work. As we saw here, let me go back to this so that we're all right there. You've got 802.11n, really the only 2 that matter in today's world for most of us are AC and N. And we will talk about bands in a moment, but on the same band, N can do 150, and this is where I'm lying to you, and if you know why I'm lying, that's okay. And AC can do 433. So AC is better if you can make it work, and we'll talk about that in a minute. Get an AC router. There's no reason in today's world to get anything that's not running AC. If you are not running it and everything is working, don't break it. There's no reason. But if you need a new router, AC is the way to go. Let's talk about bands and frequencies. 2.4 gigahertz, that's what we've been used to for were used to for a very long time. That supports B, G, and N on that chart. And 2.4 gigahertz, because it is lower than 5 gigahertz, means in theory it can go further and through more interference. It's just the way physics works, and we're all going to agree that modern physics is accurate, even though we're certain that we will be proven wrong at some point. But today, we're going to agree. 5 gigahertz, technically shorter range, but not as bad as we thought when it first came out. When 5 gigahertz was first used, really the first time we were using 5 gigahertz was a long time ago with 802.11a, and that really didn't do all that great going through walls and things like that because it was also very slow. They weren't modulating it well. Well, the good news is with 802.11n, we saw a much more efficient modulation, and hey, guess what? We could go through walls, and it really has pretty good range. And AC is really the tech that has opened up everything that we're able to do with Wi-Fi today. So 5 gigahertz, 802.11 AC, much, much better. So let's talk about this. 5 gigahertz supports both 802.11n and 802.11 AC. 802.11n at full signal strength, maxes out at 150. Yes, I'm lying. 5 gigahertz, 802.11ac at full signal strength maxes out at 433. Half signal strength, well, you know where you're going to be. Half signal strength of AC is still better than full signal strength of N. Here's an interesting thing. N works very well over both 5 and 2.4, but AC only works on 5 gigahertz. So this is why 5 can be better. Lower signal strength on AC, better than higher signal strength on 2.4 in most cases. There is no way to sit in this room and tell us how Wi-Fi is going to work in this room without testing it, let alone how Wi-Fi is going to work in a different room in another area of the country. There are so many things that can get in the way. You just have to test. But it is good to know that there are these fundamental things that probably matter in most cases. The takeaway, get yourself a router that supports both. We call this a dual band router. Tri-band routers are also okay. We'll talk about that. Usually, tri-band routers at a second 5 gigahertz band, just on a different channel. There is one out now that does 802.11ad, which we have not talked about because I don't think anyone's ever going to use it. I think it will be replaced before it's ever truly implemented in Wi-Fi 6. No, this is not a flask. Okay, we should talk about this. That's fine. It's from Tripit. It fits in your seat back pocket on the plane. It's my favorite thing to travel with because regular water bottles don't fit. So there you go. Not a flask, as far as you know. Okay. Now, you've got a dual band router. That's great. Your devices are dual band. Most of them are. In fact, I don't think I've seen a device here at the conference that isn't dual band, but certainly there are some, especially lower power devices. Your IoT devices or whatever will usually only connect to 2.4. But for the most part, our Macs and our iPhones and Windows machines and Androids and all of those things will connect to either. And they decide which to connect to. They survey the wireless landscape. They look at the signal strength of the two signals that are coming in. They also look at the names of those SSIDs. Apple devices actually prioritize by name first, signal strength second, which kind of sucks, but we'll talk about how to mitigate that. But they pick. Okay. But they are also clueless as to what your router knows unless there's a way for your router to tell them, and we will get into that too. But the device just sees the signal strength and it picks. That's how it goes. There are methods by which the router can help the device pick. And we call this band steering because we have a 2.4 gigahertz band and a 5 gigahertz band. Band steering means that the router is helping your device. The router knows more. The router knows that, yes, I might have a really strong signal to you on this band, but I'm also totally overloaded on that band, something that is impossible for a client to see. It just sees signal strength and says, I want to join too. And the router might say, well, you can, but you might get faster speed on what appears to you to be a worse option. As I said before, Apple devices go by name first. You're probably all familiar with the order of Wi-Fi networks that you can set in your system preferences. That is via iCloud, also synced over to your iPhone in the same order. If you don't use iCloud Keychain, then that's not synced. But there is still the same list on iOS, you just can't see it. So it will pick, even if the second signal is 10 times as strong as the first, it will pick the first one because that name is at the top of the list. So the way to mitigate that, set everything to a single SSID, single network name. So don't set my network 2.4 gigahertz and my network 5 gigahertz. Set them both to the same my network and let your devices choose. Then you can take advantage of something called band steering. Netgear put this graphic together, which really helps illustrate the benefits of band steering. So this on the left here is pre-band steering. So 2.4 gigahertz is purple, 5 gigahertz is green. If I'm getting those colors wrong, you can blame the fact that I am colorblind. But I don't think I am. I also would defy anyone to describe red to me, so I'm not convinced I'm colorblind until someone can do that. It's a different conversation. We can do that tonight. So here's a scenario which happens all the time, where because of the range, 2.4 gigahertz appears to be the stronger signal and the better signal, and so you will get a scenario where you've got a router, dual band, and 75% of all the clients have connected 2.4 and leaving only these few at 5 gigahertz. The 2.4 gigahertz band is overloaded. With band steering and the router helping the clients to decide, and they do this in a variety of different ways, we can balance it 50-50 and actually get more bandwidth for all clients involved. So getting a router with band steering matters. You definitely want something that will do this. It's also called Smart Connect. I don't know who started that term, but it fits. And a lot of times on routers, when you turn on Smart Connect, it makes the SSIDs the same and then enables band steering so that the router is helping. Oftentimes, what the router will do is it will actually deny the request for the device to join on the 2.4 gigahertz channel so that it is forced to attempt again. The device, again, thinks it is the one making the decision, tries one, says that failed, let me try another, that succeeded. That's how the router, oftentimes, that's how the router is doing it. And I knew this thing was going to come off. All right, good. Make sense? Everybody good? Any questions? I'm trying to go quickly so we can get to like the overall questions, but am I going too fast? Perfect. Synology, Plume, Netgear, Linksys, Luma, TP-Link, Ubiquiti all have this Smart Connect in their standalone and mesh products as well. In fact, almost every mesh product uses Smart Connect and just the single SSID. We'll get into mesh, but there you go. Okay, now I know this might seem boring, but it's actually really fun, and I think for this crowd maybe it's extra fun. I know I lied to you before about how fast 802.11n and AC were, and that's because we were talking about only one stream, only one antenna's worth of 802.11n. So each antenna for 802.11n goes 150 megabits a second, maximum theoretical throughput. You'll never see that. Each antenna for 802.11 AC goes at 433 megabits per second. Again, theoretical maximum. But those protocols allow you to run the same network over multiple antennas. And that's where things get interesting. So you will see routers advertised as this is a 2x2 router or a 3x3 or a 4x4. This is a speed multiplier because it's telling you how many antennas per band it has. As I said, 802.11n is 150. Well, if we have two of them, and the way these numbers work is, and I forget which order, it doesn't matter. One of them is on the transmit side and one is on the receive. 99% of the time, it's going to be the same number on both sides because it's the same number, it's the same antennas. You might as well just do it that way. So 2x2 means you get 300 megabits theoretical maximum in each direction. 3x3, again, on 802.11n, 450. 4x4, 600. 802.11 AC is the same thing. You get 433, 866, 1300, 1700. Yes, I'm rounding. It's okay. You'll see, we all round. It's part of the deal. It's part of the industry. So does that make sense? This is, okay. The clients need to support it, because if the client only has one antenna, it does matter. For speeds, speed multipliers, it does not matter how much the router has, because the client only has one antenna. Most of your devices are 2x2 devices. I think the 15-inch MacBook Pros with Touch Bar are 3x3 devices. Your iMacs have been 3x3 devices for a long time. Am I getting that wrong, or am I getting that right? Your iPhones and iPads are all 2x2. So the deal is, and this is called multiple in, multiple out. Makes sense, right? We like acronyms, so that's MIMO. Multiple in, multiple out. That's all this means. 4 streams in, 4 streams out, 3 streams in, 3 streams out, multiples. The takeaway is if you're getting a standalone router, this is different from mesh. If you're getting a standalone router, get at least 3x3, because you want the extra antenna, and we'll go into why in a minute here. But you want at least 3x3 for a standalone router. With mesh, this is going to be different advice. Let's talk about router marketing speeds, where we like to lie. Well, they like to lie. So You'll see routers marketed this way. This is an AC1200 router. What that means, it has two 2x2 radios, one 2.4 gigahertz, one 5 gigahertz. So 2.4 at 802.11n, we already did the math, that's 300. We did the math on two of these radios of 802.11ac, that's 866, that's 1166. Guess what, we've rounded up. It's marketing speak, so that's AC1200. It's an 1166 theoretical. You will never have a client, somebody's gonna tell me I'm a liar, it's fine. You will never have a client that takes advantage of all 4 antennas at the same time. Your clients generally are gonna connect to one or the other. This is the router's maximum speed, not the speed you're gonna see per client. Make sense? Cool. AC1700, again, we're just doing math. We've got 3 streams per radio, so we've got 450 plus 1300. Why the marketing people decided to take 1750 and round it down, we will never know. Buffalo, to my knowledge, is the only company that ever called their routers AC1800, and no one ever said AC1750. So, yeah, this is all this means. Make sense? Cool. AC1900, this is where things start to get a little bit interesting, and you'll see a lot of routers like this. It'll have a 4x4 2.4 and a 3x3 5 gigahertz. We can do the math. That's actually, well, it's not really 1900, is it? But sure is close enough, and we like to do that. Again, router speeds, not client speeds. Now that we understand the number of antennas, the number of streams, the number of beams sent by the router, we can talk about beamforming. So here we have your 2x2 MacBook, okay? And this is a 3x3 router. How do we know? We have 3 antennas. You won't always see the antennas, but for the sake of our demo here, I wanted to show them. So we have a 2x2 device. It can only connect 2 streams, but here's the cool part. The router can get involved in this, the router can help the client, by using a technology called beamforming, decide which of those 2 streams is the best to use at any given point in time. A lot of times, the way routers are built, the antenna will, each antenna will be aimed in a slightly different direction to get, omnidirectional coverage, and depending on the location and even the orientation of your laptop or your iPhone or whatever, you might connect to, these 2 or these 2, and it will go back and forth, no problem. This is how beamforming works. It's very cool. It is a tech that you want. Most routers support it these days, but not all. There was a time, maybe 3 or 4 years ago, where it was easy to buy a router that did not yet support this. There are 2 different types of beamforming, implicit and explicit. Explicit beamforming is when both the router and the client device know about how to do beamforming and know how to negotiate that. That generally only happens on 802.11ac, the 5 gigahertz stuff. Implicit beamforming is when the router says, nah, I'm just going to nudge you over there anyway, even though you're not involved in the conversation. That's happening on 2.4 because there's no real spec for how to implement that on both sides. But beamforming is a thing you want because you want it to pick the right 2 antennas. Even though you've only got 2 here and 3 here, you actually get better speeds because you get antennas that are aimed better. So, we talked about MIMO, multiple in, multiple out. It just means multiple streams. But there's single-user MIMO, and there's multi-user MIMO. MU MIMO, SU MIMO. You've probably seen these terms. I know, they're not fun. It's after lunch. You want to sleep. No, you don't. You can sleep on Saturday. You can sleep on the plane home, whatever it is. We'll get through this. We'll take care of it. Then we get to go see the sunset after another session. It's fun. So here we're back to our trusty router and our MacBook, and now we've added an iPhone into the mix. This is an iPhone that supports 2 radios. It's a 2x2 device. So let's talk about single-user MIMO. The way single-user MIMO works is only one device can talk to the router at a time. I know you think all of your devices are talking to the router simultaneously. It sure seems like that. They're all associated with it. But really the way that it works in single-user MIMO scenarios, which is the default, is that only one device gets to talk at a time, okay? And so what happens is it does this, right? The router says, I know these 2 antennas are the right ones for that iPhone, and these 2 are the right one's for this MacBook, but we just have to go back and forth as they like, as they need data. And they try to balance this out. There's things called airtime fairness, and this is actually why when we moved from years ago, you might have heard that if you were running 802.11g devices on your end network, it would slow things down. It didn't actually slow things down, but what happened, and we're a geeky crowd, so I hope that you'll appreciate this, what would happen is the way the router decided when to switch was after a fixed number of bits were sent. So if, for example, it's not true, but if, for example, the iPhone was a B device and the router, the laptop was an N device, and it decided to send, 1,000 bits across to each before switching to the other, it would spend more time on the iPhone than it would on the MacBook, effectively, yes, slowing down what the MacBook could do. Airtime fairness. Everybody remember that term, airtime fairness? I'm the only one. Cool. So airtime fairness was a thing that instead of doing it by data sent, it did it by time. And it said, you get X number of milliseconds, and then I will move on from you, regardless of how much data you sent. And that helped. So anyway, that's single-user MIMO, just bouncing back and forth. Here's multi-user MIMO, right? Because we've got these two going here. We've got this one going there. That sounds like a good idea. Here's the thing about multi-user MIMO. Every single device associated with the access point needs to support it, or it doesn't work. Here's the other piece of news for you. None of you can use it because you have Apple devices, and Apple devices do not support MU MIMO yet. I'm not sure they ever will. I feel like that ship might have already sailed, and we'll talk about why when we get to the mesh part of things. But Apple devices have never supported MU MIMO. I don't think that changed last week with any of the announcements. And that means if you have even a single Apple device associated with your Wi-Fi radio, none of your other devices, even that support MU MIMO, will do it. So here's the deal. I know. It's great if you can do it, because it truly does make things more efficient. You actually get data being sent to both devices or multiple devices simultaneously. This can really make a difference when you've got multiple people in the house streaming Netflix and that sort of thing, because the router's not having to shift back and forth. It really can. YouTube's actually more important than Netflix because Netflix does a pretty good job of buffering on the client side. YouTube, sometimes less so. The videos are just shorter, so people tend to jump around a lot, and you can't buffer what you're going to watch next because you don't know. So it's great, but you can't use it. Don't sweat it. There are other ways to solve this problem. So MU MIMO is not it, but it's good to understand it as we move on here. What's that? A lot of Windows machines do. Most Dells, I think, support it. There are some Android machines that support it, or Android devices, tablets. Yeah. It's a feature of the Wi-Fi chipset. It may actually be in the chipsets that we have, but it's just not on. Yeah. Correct. On that radio. So if you have a dual band router, each band is responsible for its own thing, but you won't do MU MIMO on 2.4, so it's only on the 5, et cetera, et cetera. If you have an office of 20 people, the odds are somebody's got something that's going to wipe it out. That's correct. That's correct. Yep, that's right. And I'm sorry, what's that? Somebody comes in with an iPhone, right. Well, so what you could do in that scenario, and skipping ahead a little bit, you could get a tri-band router with two 5 gigahertz bands. You could name one of those the 5 gigahertz MU MIMO only band, and only give the password for that, therefore only associate devices that truly support MU MIMO. And you can skin that cat, if that doesn't offend anybody. We talked about stabbing yesterday, so I think skinning cats is probably okay. Quality of service. This is the one that's actually important to you, whether you know it or not. It's going to be boring. It's time to wake up, because this is going to be fun. There's a lot of things that fall under the QoS umbrella. What we're talking about here is using the part of QoS to ensure that no one device hogs all your bandwidth. Think about, when your Backblaze backups are happening or your iCloud photo library backups. A great example is you come home and you know, you were out with your family and at the zoo, and you all took a bunch of pictures, and now you get home and you all throw your iPhones down on the counter because you're back at the house, and they associate with your Wi-Fi network, of course, in the background, start uploading all those great photos you took. You sit down at your computer to check your email, and everything is slow. The problem is that your upstream, the signal back up to the cloud or the rest of the internet, is now choked by all of these phones that are uploading these photos, and nothing is doing a good job of managing that. So all of your outbound requests, even just to check your email, take forever, and this is a problem. It's because of your cable modem. It's very bad at this by design, because your cable modem has to fix your bandwidth at a limit, and it does it in a very, very poor way. And I'm lying again, and I'll tell you why in a minute. Let's do a little bit of diagramming. So here's our funnel with all of our bits going out. The only part we care about is this, right? The part leaving our houses or our offices with our cable modems, because this is where the bottleneck begins. I am not good at keynote art, but this is awesome, what you're about to see. I'm telling you it's awesome so that you will believe that. Great. So here's our funnel. The problem is I've made these angles a little too steep, and you'll see what I mean. So here's all our bits, right? Everything's good as long as we're not sending more data than can fit in this pipe at any one point in time. That pipe, of course, is our artificial limit that is imposed by the plan that we choose to buy in terms of our upstream speed. Here's the problem. When we add more in, we are full, right? So we add more in. In theory, you would think it would just start funneling out real nice. No, no. It's like this is an electric fence, and those are all bodies. And as soon as you hit it, your packet is sent to the back of the line. So if you send one bit faster than you can go on the outbound, things don't get queued in order. They start going to the back of the line, and it can really screw things up. This is bad. The modem is doing this, correct. And you can't change this about your modem. So you have to deal with it ahead of time and only send it. Really, the trick is you have to send it data just shy of its limit so that the modem never does that to you. Make sense? My diagram was awesome, right? Helped explain it? There we are. Thank you. It's just how it was designed. It's called the queuing algorithm that's in it, and it has to choose, it has to be able to, brick wall the bandwidth so that by simply shoving more at it, you're not getting more than you're paying for. That's really what it is. And I'll jump to the end. I'm lying about this, sort of. The Cable Labs decided this is bad, and so they put in the DOCSIS 3.1 spec, which is for gigabit speeds. They said you have to use this new queuing algorithm called DOCSIS Pi that is way better at this and, in fact, completely mitigates it in all but the rarest cases. The good news is it's solved across the board in every DOCSIS 3.1 modem. So even if you don't have DOCSIS 3.1 speeds, it will fall back to 3.0, but it has to use the new queuing algorithm. So if you want to solve this, you could upgrade to a DOCSIS 3.0 cable modem, even if you're not using 3.1. Because 3.1, theoretically, uses a different queuing methodology entirely. It's using OFDM, and essentially it's like what we did with AC. It just squeezes more into the same pipe by modulating it differently. You want your router to arrange it. That's correct. But we need to think that, so that's right. That's how we solve this. The problem is that actually takes a not insignificant amount of CPU power because it's managing all of these packets that are just flowing all the time. But that is the solution. So you want a router that supports QoS specific, not Wi-Fi QoS, but what they generally call it is WAN port QoS, your internet port, your wide area network port. That's this. There is also a QoS that does similar things for Wi-Fi in your house. Most routers already support that, but you do want that too. It's not as important, though, as this. And unfortunately, this is less common. So, WAN-based QoS. Yep. So the vendors that do this Synology, eero, Orbi, and Luma do this. Netgear basically does it across the board in all of their routers. Almost all of their routers. Be on the lookout for it. Yeah?
So is this sort of algorithm and method like a way for the ISPs to kind of bottleneck our traffic based on the type of service it is?
No. Yeah, so the question was, is this used by the ISPs to block different types of bandwidth? And the answer is no. Everything is mistreated equally.
Oh, okay.
Yeah. It's whatever the packet is that happens to show up, last while there's a line, gets sent to the back of the line, behind the person behind them. It's a really inefficient thing. It's just, yeah. So thank you, Andy. Yeah.
If we have questions, let's get a mic to you, because otherwise it won't wind up in the video.
You won't. Oh, yeah.
No, I can do it.
Okay. Yeah.
How does the modem doesn't know the maximum upstream speed? So how can it regulate?
Actually, the modem does.
Oh, does it?
Yeah. When you sign up for service.
I'm sorry, not the modem. I meant the router. I apologize.
Good question. The router doesn't know the maximum upstream speed unless you tell it. Now, some routers will auto-detect. They'll do a speed test and use that. You can also override that in some routers where you put that in. And other routers I found, like Synology's, I actually set it to way higher than what I know my upstream to be, and it's totally okay. Whatever they're doing with their queuing actually, I don't know, seems to do fine. So, yeah. Cool. Good. Moving on. All right. We started this and said that your devices pick where to connect, how to connect, what to do, and they don't know what the router knows. But of course, we're geeks in general, and we're all geeks. That's okay. But in general, there's a lot of geeks that think about this stuff and had said, well, that doesn't need to be a universal truth forever. We could inform the devices of things that the router knows, and we can help them. And so there are these three texts, and we're going to start talking about mesh in a minute. But I wanted to include this in the pre-mesh part, even though this mostly applies to mesh. And they're called 802.11k, V, and R. Here's the beautiful part. We've already talked about 802.11a, B, G, N, and AC, and all of those are signaling methods, aka speeds. This has nothing to do with speeds. It's just different. As you move from access point to access point, which is what you generally do in a mesh scenario. 802.11k pre-informs devices about nearby access points so that they have the information about them without having to go and look. It tells them, hey, you're on, the MacTech attendee network. You should also know that there's these other access points with these unique IDs out there that you will find on this same network. And so prioritize those before you go just looking randomly at the IHG Hotels network or whatever. It can just make things faster. 802.11v lets the router tell the client, hey, don't join me. I'm busy, but that one's not. So join that one instead, even though, yeah, I know it looks like it's further away. Go take plan B. So that's the polite way instead of just saying you're not allowed. It's, nope, here, let me give you some information. Now you can still choose. And 802.11r, this is the one that keeps coming up kind of in the Wi-Fi news because it can mess with things because a lot of companies, aka Apple and others, haven't quite implemented this the right way. R pre-shares the authentication keys so that you don't need to renegotiate security settings when you jump from one access point to another. This can be very helpful when you're doing, like you're on a FaceTime call and you happen to be moving around the house. You've seen it where it joins and there's a lag because it has to truly fully renegotiate with the point. Well, not with R, if that makes sense. Except if R breaks and then you can't even, then you have no signal. That's where it gets fun. Yeah? Isn't R on WPA? Yeah, right, because the key can be leaked through R. It can, yes, yeah. That's correct, that's correct. It's also strongly discouraged just because a lot of devices don't it's sort of, there's an incompatibility in the standard, which is oxymoron, except in practice. So, what about your ISP's router, right? Because that's a default not only for you, but a lot of your clients. You know, the reality is, if you keep your ISP's router current, oftentimes there's no reason not to keep it. But if you are paying $10 a month to them once a year, you should go to your ISP or have your clients go to your ISP or go to the ISP on behalf of your client and ask them for an update, because you're paying $120 a year for that router. You should have what they want to give you most currently. And a lot of times that'll be great, and then you get the benefit of them also managing it and supporting it and all of that. But if you're going to spend money on your router, it should be better than what you're going to get from your ISP. Otherwise, you're kind of being crazy about it. So, some of my favorite standalone routers. My current favorite, and this is hands down my favorite, is the Synology RT2600AC. It's $199. It is a dual band router with 2 4x4 radios. Because of those 4x4 radios, things go far and they go fast. We've already been through why. The radios can negotiate the right ones to use. It's really a stellar router. On top of that, it has QoS, it has band steering, it has a DNS server that you can run in it, because it's based on the foundation of Synology's disk stations that have been around for, you know, decade plus. They've got a beautiful web interface, they've got a great iOS app. It really is, like, if you need to replace your Airport Extreme, 100% of the time I answer with this. It's a much better router than that, and it's, you know, it's priced pretty fairly. And now they have mesh features, which we'll talk about in a minute. For the budget conscious, this TP-Link Archer C9, it's been around for a really long time, so you can get it for $74. It's a dual band 3x3 router. You know, for certainly every apartment, I would think, and most even small to moderate sized homes, it's going to be fine. And the Netgear R7800 has some interesting gaming features. It too is a dual band 4x4 router. It has some things like inbound VPN, which did I put that up here? I didn't. The Synology also has inbound VPN, which is another cool thing for us geeks. It's a really fun router. Did I say that? It's great. Okay, any questions on any of that before we get into mesh? I have 12 minutes left, so I'm going to take a drink while you think and write. We're doing good. Okay. Essentially what mesh is multiple access points working together. They're all using the same network name, as we mentioned before, all the same encryption, so that negotiating with one is the same. You don't have to have different passwords for different things. You don't have to have different names. All managed from one interface. This is if you're not managing it from one interface, let's not call it mesh. You can create quasi-mesh, which many of us have been doing for many years before any of this ever entered the market. And theoretically, it's all intelligently managed, some more so than others, as things always are. It's different from range extenders, although range extenders have gotten a lot better lately because of 802.11ac. There are some range extenders that now call themselves mesh things, like the Netgear Nighthawk does the whole Nighthawk mesh thing, even on old hardware. It's inheriting your security settings and giving it the same name. And so if you're happy with your router, but you want more coverage, these meshing range extenders can actually be pretty good. But mesh is better, where you really truly only have the one interface, if that makes sense. And here's the idea, right? You know, you have your cable modem come into there, your signal comes into the house, doesn't really matter. And in one area, so that's where you put your router, and next to that you get great signal, and then as you get, you know, over here, and the porch is screwed, right? Things go down and down and down. You get too many walls, and that's the end of it. Mesh, you're adding access points around so that that signal can be essentially echoed. I mean, when we're talking about a wireless mesh, that's what's happening, is it's taking your wireless signal and sharing it, but it's doing it intelligently. Both sides know, like all three of these devices know about each other. One isn't trying to grab that. Like in an extender scenario, if you put an extender here, your router has no idea that that extender exists. It can't do anything to help it. Whereas in mesh, everything works together, and it really, it can make a, is anybody here running mesh at home? Yeah, and for those of you that are, I know some of us just like to run it because it's cool, but for those of you that are, show of hands for where it made a big difference in your house. Yep, all the same hands, yep. So even when you think, yeah, 2 hands up. Ah, there you go. It really makes a difference, not just for coverage, but for things like speed, because you have more access points for people to connect to. And that's really the thing, right? We get coverage out of it for the obvious reasons. But that multi-device throughput, remember we talked about MU-MIMO, and we said we wanted to have multiple devices connected simultaneously, but our Apple devices won't do that. Well, if you have 3 mesh points in your house, guess how many devices can simultaneously be talking to those mesh points? 3. This now makes a big difference, even in a house where you had plenty of good Wi-Fi coverage from the single router because your house was perfectly built and the router can be in the dead center, exactly where you want it. It's still just the one router. With mesh, it really can make a difference, especially if you've got multiple people in the house streaming, like I said, YouTube or Netflix or really anything. Makes a big difference. And the nice part about mesh is it is truly set it and forget it. Ron Popeil, if he was going to make a network product, this is what he would make, because you just set it up and you don't worry about it. And if there is a problem, it tells you. That's what we want. Perfect. We love that. It really is a good thing. It takes some of the geeky element out of it, though. So if you like having a headache of managing your network, I kind of do. I got to be honest. So like it takes that away. It's like, no, we'll solve that for you. But like maybe there's a different headache you can have fun with, like Raspberry Pi instead, and then there you go. More features, yeah. Okay, so let's talk about mesh options. Hardware is more important than software because once you have hardware, you can't change it, but you can change the software, except that software is the most important thing because it doesn't matter how good the hardware is. If the software is crappy, then it doesn't matter how good the hardware is. So software is important, and this is where it gets tough because you have to kind of look at what someone's already done and hope that they will continue acting in the same way. One big thing, and especially for us geeks, is some meshes are cloud managed and some are locally managed. With your standalone routers, 99% of the time you are used to what we call locally managed, meaning that router, you connect directly to it, usually with a web interface, but with Apple stuff, obviously it was Airport Utility. That was all still locally managed. You're talking directly to it, manipulating its settings, all good. Doesn't matter whether you have internet access or not, you can change your router's settings. Cloud managed means that you are not talking directly to your router. You are talking to your router's manufacturer's cloud, and then it talks back down. There is actually a security improvement there because it means that someone on your network can't hack into your router. It means that someone on any network could hack into your router manufacturer's account, though. So, pick and choose wisely. For some people, this is a religion, which is why I mentioned it. Some people will not buy mesh products that use cloud managed, and I get that. That's fine. I'm not in that group, but I get it. It totally makes sense. You also want to think about your backhaul. Most mesh products are built, in fact, all consumer mesh products are built to do wireless backhaul. By backhaul, I mean, how do the mesh points all communicate with each other? Ethernet's better, though, because you get to, you're freeing up your Wi-Fi band. Yeah?
Amplify will let you take the main router and use it as extensions wired.
Correct. That's right. Yeah, and a lot of them will. That's right. Yeah, and it's just an option to consider when you're looking at this. If you have already put Ethernet in your walls for the purpose of solving Wi-Fi problems, make sure you get a mesh solution that will take advantage of that. There's no reason to go backwards. And I know a lot of us have. And if you've built a house, hopefully you've put Ethernet in the walls and you can use them. So it makes a difference. eero is my current favorite mesh. Okay. It is the oldest mesh in the market. That's not entirely true. Really, for consumer-facing stuff, Sonos is the oldest wireless mesh in the market. And you could actually use Sonos to send other network data across it. We're not going to get into that. We don't have time. But a lot of the smart vendors actually learned a lot from Sonos when they came into the market, because it's a weird thing to create these meshes in homes where you can't predict what's going to happen. The original was a dual band 2x2 per device. That's actually plenty in most scenarios because you're adding multiple devices. They have new tri-band units that are still 2x2 radios. So they've got 2 5 gigahertz and 1 2.4. That frees up another radio for backhaul if necessary, which can make it really efficient. So if you're doing wireless backhaul, the tri-band stuff makes a big difference. If you're doing Ethernet, it does honestly not that much for most of us. They have the most mature software, although there are some others that are coming right up on their heels, which is good. That's a good thing for us.
Were you going to, the beacon, even though it's quote unquote new, I think it's also only dual band.
It's only dual band, that's correct. Yeah, the eero beacon is a wireless-only device that is only dual band, that's correct. Yeah. It does support Ethernet backhaul on devices that have Ethernet ports. They recently added QoS. They call it Smart Queue Management, SQM. It is $399 for a 3-pack with 1 tri-band eero and 2 dual-band beacons. So there you go. The beacons do not do Ethernet. So pick and choose what works for your home.
They also sell a kit called the Eero Pro, which is
With 3 of the tri-bands. Yep. And here's what the web interface looks like. I'm going quickly because I want to show you some other options before we leave. So I told you that eero is my favorite, but Plume is the one that I'm using. Came out with their 2nd gen tri-band, the same 2 2x2 radios, and then they added a 4x4 5 gigahertz radio to this. This makes a huge difference. It's super intelligent. It picks my daughter has a MacBook Pro that's got a 3x3 radio in it, and it automatically forced her to choose that one because she gets more bandwidth. She can take advantage of it. It's really smart. It goes really far. It has the best roaming. The roaming is so fast. You move from one room to the other, and you can see it jump from one to the other. They all support Ethernet backhaul. They do not yet do QoS, and this is why it is not at the top of my list. It may change. Software matters. Not really. I don't. If it does, then that's new, and I could be. I think it's like within the last 10 days. That would okay. Then that's possible. I've been traveling. Okay. All right. They've told me it's coming, but I've had a lot of vendors tell me things like that. So vaporware is a thing. All right, so I have 90 seconds left. So it's $399 for a 3-pack of SuperPods. They also have a membership model. The 3-pack comes with a lifetime membership. You can buy, months. Synology is the other new one I want to mention before we all leave. Synology is new to mesh, but not new to the router market. They just came out with their MR2200. It's a tri-band, all 2x2 radios. You can add this to any router you have, including a Synology router, or it's its own router. It comes with QoS, Ethernet backhaul, Cloud Station, which is like running your own Dropbox, the VPN server, the DNS server, all of that stuff. So this is the new one to really watch. And I think that's where Andy is going to tell me we have to stop.
Well, we're coming. We got another minute, so push. How long will it take you to complete?
No. I'm basically done. I mean, I can talk about this all day long, but I've gotten the
Are there
things
any
out
slides that you want to hit before?
Nope.
Okay.
How does Orbi compare? Here's the problem with Orbi. I'm glad you asked that question. Great hardware. Well-known vendor, Netgear, obviously. They chose to come out of the box with 2 odd feature choices. 1, no Ethernet backhaul, even though every one of the devices has like 4 Ethernet ports on it. So yeah, so that was odd, and they fixed that with an asterisk. And then they also chose, again, out of the box, not to do what the industry calls multi-hop. So if you have your base station here, and then you've got a room here, and so you put another one in, and then another room over there, that one over there needs to talk back to the main one, not the middle one. And in some scenarios, that's a deal breaker. They have patched their software to address both of those things. but they've had a lot of bugs with that because fundamentally their software was written for star configuration, Wi-Fi backhaul only. So it takes the network a while to adapt to these changes. It's wonky. Once you get it working, as long as the power doesn't go out, it's great. But I can recommend it in specific scenarios where I know it's not going to be a problem. But in terms of universally to a room like this, I have to say no. Yeah, unfortunately. So
We take one more
we'll
Tanya
let
question.
Tanya go.
Okay, here's my question. Would you recommend purchasing a slightly cheaper scenario because realistically in 3 years we're going to have to upgrade the whole thing anyway to support more new awesome features? Or would you recommend spending more money and truly setting and forgetting it for as long as possible?
Yeah, I would go with Plan B. I would always go with Plan B because you can't drive yourself crazy worrying about what's going to come out tomorrow. It's like, what devices do you have today? What works today? What software, what hardware is reliable and known good? Which vendors have actually been paying attention? And the 3 that I've showed you for the mesh here are among those. And they are not the only ones, but they are.
And I'm assuming you'd recommend wired whenever possible.
Wired
to
backhaul
support, right.
whenever possible, absolutely. And the bonus, if you don't have wired backhaul or you don't have Ethernet in your walls, but you do have coax, you can get the Action Tech Mocha stuff. It's freaking amazing. If you get the bonded stuff, it goes like 800 megabits, almost gigabit Ethernet. So good stuff.
But
I
an
will
interesting
answer your
little.
question outside.
Yeah. Just one thing. A little interesting thing is if you look at the new Ruckus access point out there, it's got a 5 gigabit Ethernet port.
Yeah.
So
Yeah.
in order to take advantage of it. But that's an indication of what they're looking for in terms of wired side. We really have to go. I'll take one more question, but we got to get you the mic. So
Addressing the lady's comment on buy cheap or not.
Yeah.
If you don't buy the cheap, you're almost guaranteed for me these major guys to get an update every 2 or 3 weeks because
Correct.
this is all brand new.
Yeah.
I've been working with
Well,
a lot
I mean,
of amplifying ubiquity stuff, and it's like once a week somebody wants to update the switch, the router, the access point, or
That's
something
right.
else. Which, if you go low end, you're less likely to get that stuff.
And Google Wi-Fi is a odd example of that. They update occasionally, but they don't seem to really care about it. So it's really fast and it's reliable, but I don't know if this is going to be a thing that they stop caring about. So, thank you.
Dave Hamilton, we got to go. We got to move on. Thank you.
Thanks, Andy. It's great.